No.
Let's start. The genetic code. In vitro translation of synthetic
How will I
polynucleotides.
see if it's...
No, you just you have the note. Just
Yeah.
see my
Oh,
hands.
okay,
Yeah. In vitro translation of synthetic polynucleotide, a monotone polynucleotide and copolymer used as a template in Nuremberg mixture. Amino acid. What's happened here? The Nuremberg tries to understand which amino acid, which codon. How? He synthesized one chain of U. He put all of the amino acid there and understand just phenylalanine bonds to that and understand, okay, the phenylalanine is U. And
What
this
is
is a
U?
phenylalanine
Like-
U.
Like uracil?
See, U and U is a phenylalanine.
Ah.
Understand this three codon. Then he tries the different one and said, okay, and okay, is what? And is lysine.
Okay.
In this case, but Nuremberg distinguished the genetic codon.
But did he add the lysine on it?
Yes, he was a very jobless person. He do a lot of experiment in 20 years. After 20 years, he understand and he discovered all of the genetic codon
Really?
and gift it to the medical student. Please memorize it. Nuremberg mixture.
Fuck you.
In this mixture, we have a template. This is a template.
Yes.
We have a copolymer. We have a polynucleotide. We have a tRNA, amino acid tRNA binding assay. The Nuremberg
What are
system.
these two? What are these?
Polynucleotide.
No, a
Copolymer is a helper of the polymer.
Okay.
For example, I don't know also. It's a copolymer.
Okay.
Always we had copolymer.
Okay.
Copolymer prevent aggregation, helps the processes, speed up the process.
Okay.
Everything.
Okay.
Everything good is a job of the copolymer, okay?
Okay.
And Nuremberg system, omission of GTP, amino acid tRNA binding, but no protein synthesis, just filter binding. In the Nuremberg, the omission of GTP. Okay, why we should remove the GTP? What was the role of GTP? Amino acid tRNA binding. Okay, because now already we add the prepare amino acid tRNA. We don't need to produce new tRNA. Back. This is the ATP.
Yeah.
Okay, and the GTP, it was cap formation also. Do you remember cap formation needs GTP?
Yeah.
It was somewhere here. GTP needs their energy. Energy, we don't need it. Amino acid tRNA binding, but no protein synthesis. For protein synthesis, we need GTP. Do you know where?
Does this say that you don't need GTP?
We know. We should remove the
Okay.
GTP. Omission.
Okay.
This is a GTP.
Yeah.
Somewhere here. It's here. See? This photo initiation factor should bind to GTP.
Yes.
Understand it?
Yes.
If we omit the GTP, it means we cannot do protein synthesis. Just amino acid bonds tRNA.
Okay.
And filter binding. Filter, how it's filter? By omission of GTP.
Mm-hmm.
What was the story? We add the template to
Yeah.
distinguish which amino acid,
Mm-hmm.
which codon, which codon.
Which codon?
Which
Yeah.
amino acid, which codon.
Mhm.
Features of the genetic code.
But sorry, you only have the template and then you add amino acids.
Yes. And
Yes.
then this is bond, the other is not bond. And they have, for example, fluorescence color.
Yeah.
And we understand which of them is bond, which of
Codon.
them not.
Okay.
And this is a filter. See, maybe instead of fluorescence, he used a filter. This is a big one. Cannot pass through that, the other pass.
Okay.
I think this photo wants to set us they are pass, the other not pass. Filtering.
And you used 20 years for this?
Yeah, maybe. This is an example, just to memorize it, please. I'm not a teacher.
I know.
I'm just like you. I just remember it like that.
10-second break. 10-second break.
Features of genetic code. Triplet. Okay, all of the genetic code are triplet. Bacteriophage experiment. What is the bacteriophage?
You said that.
Is
one
it a
day.
virus or is it a
It's
bacteria?
both, isn't it?
Fuck me. What is the bacteriophage?
It's like a virus with
Is it that's a virus?
Yeah.
Can infect the
host
bacteria.
bacteria, yeah.
Again,
It's a virus that can
it's a virus
that can
can infect bacteria, both. No, insertion, come.
Yeah.
Insertion of one or two extra nucleotide into a gene of a phage coded protein become inactive. For the insertion of one or two extra nucleotide into the gene of the virus, of the phage or virus, the coded protein become inactive.
The coded protein will. Okay, so if you add some of the, so like add some nucleotides
This is
to the
DNA,
phage,
and I
to
add
DNA
this
of the phage.
Yes, and the coded is inactive. Insertion of trinucleotide protein remain active. Why? Because if you add a trinucleotide, you make a new codon.
Yeah.
But if you add one or two extra nucleotide, you rearrange, you disarrange, you fuck the arrangement of the tri. Understand?
Yeah.
Conclusion, coding region, reading frame consists of triplet nucleotide. Insertion or deletion of one or two nucleotide, frame shift mutation, fuck the codon. Understand? One or two is bad because the frame shift mutate. For example, imagine that this is a 1 3, again 1 3, 1 3, 1 3. Now I add this one here, I add this one here. What's happened? This is again 3, 3, but here is this.
Yeah.
And this is the next one. This is a shift. This is a mutation. Not good.
Yeah.
Not bad. This is a bad one.
When do you have a stop codon then?
Maybe, for example, if this was A and this was U and U are A, this is a codon formation and it's finished.
Okay.
Finish here. Again, this is a bad protein. We don't need this one. We need whole. It's completely healthy. Again, one of the features
It's
of
bad.
genetic code is a triplet. Who
Yes.
proved the triplet? How could you prove the triplet code? You said if I add one or two nucleotide to the gene of the bacteriophage, the coded
the-
protein become fucked.
Inactive. Fucked.
Fucked.
Can
If
be
we
mutated, right?
Yes,
The
this is a
protein-
frame shift mutation. The name of this mutation is
Frame
frame
shift.
shift. But if we add trinucleotide, protein remain active. It means the codon is triplet.
Yes.
Again,
Is this like here, isn't it?
what? No, we wanna.
Three nucleotides.
See, the normal gene is 3, the threonine, serine, tyrosine, proline, histidine, threonine again. The codon, fuck it. Plus one nucleotide, what's happened? Inactive protein. Why? I add here one G before the U, between G and U. See? Now, instead of serine, I have valine. Instead of tyrosine, I have isoleucine, serine, alanine. This is completely different than this. This is the inactive protein. Two nucleotide I add G and A. GAU is asparagine, histidine. It's a completely different. It's inactive. But if I add trinucleotide, it means the aspar just I add one amino acid, but the other remain unchanged. See, this is serine, this is serine, tyrosine, proline, histidine. This is the active protein. Understand
Yeah, I
it?
understand. Because they have to be three
This is
all
a
the time, right?
this experiment prove the code is triplet. Prove the code is
Triplet.
triplet. Now comes here. Now you understand
Yeah.
how many we have. We have 64 codon. 61 is sense. They have an amino acid. 3 is nonsense. It means it's a stop codon. You learn it. The code is redundant. What does it mean redundant? It means it can degenerate. One amino acid can be coded by more than one codon. It means it's a redundant.
One. I mean, that's
How
good.
many tooths do you have?
Me?
You.
I don't know.
32.
Oh yeah, like generally.
When you eat the meat, it means you bite it by 32. You have one mouse, you eat one meat, but you add 32. We have one amino acid, but we have 32 codon, for example, for one of them. It means it's a 32 dendate. Now it's written here redundate. Redundate. For example, phenylalanine. See, phenylalanine. UUC. Again, phenylalanine, some were not. But you see, all of them are leucine. CUU, CUC, CUR, CUG. CU by everything is leucine. Everything by CC is proline. Understand?
Okay, so one amino acid can be coded by more than one.
What does it mean the amino acid and the code is degenerate? Degenerate is an important feature. I want to write the name of the numbering feature of the genetic code. First, the genetic code is triplet.
Yes.
The second, the genetic code is redundant. 3, the genetic code make
What
a
did it
vowel.
mean? What did it mean that it was redundant?
Redundant means degenerate. It means one amino acid
Can
coded
be.
by more than one codon, like a mouse and teeth.
Yeah.
Vowel means uncertainty at the third codon position. This is a vowel. For example, see, it was a CU, and by everything else, this is a leucine.
Yes.
In this case, the tRNA, we don't have a 4 tRNA for the leucine. We said this is a C, this is a CU by OUGC. This is a leucine. Yes?
Yes.
In this case, what is the complementary of C? G. Complementary of U? O. And complementary of all of them together is inosine. Again, the complementary of all of them together is inosine. 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 This is the uncertainty. It means the I is calm. Okay, who cares? This is the A or C or G or U. That's important that inosine can point to everything, and C and U, and this is a leucine for sure, because all of them are leucine. All of them are proline. All of them are serine.
So what? The third one will.
The third one, the uncertainty at the third codon position. I'm not sure, is it a U, C, or A, or G? But because the first is C and G, for sure this is arginine.
Okay.
Understand?
But will the third one determine which amino acid it will be?
Yes. No. Just the first and second can
They will
determine
be.
the amino acid.
So it doesn't matter which.
It
one
doesn't
this one-
matter. It is the uncertainty at the
Okay.
third position.
Okay.
This
It's
is
a
very
vowel.
important. The code is unambiguous. Unambiguous means a codon codes for a single amino acid. A codon codes for a single. For sure, if the UUU is phenylalanine, the UUU never could be a glycine.
Okay.
Is unambiguous. It is especially. This is specific. Unambiguous. The code is continuous. What does it mean? It means no punctuation, no overlapping. What does it mean? If this is a code, if you read it like that, you cannot say this is this, and I would like to read it like that. 1 from here, 2 from there. Never. Not overlapping. This is forbidden. Just this is okay. Okay? No punctuation, no overlapping. It means the code is continuous, not back. This is a fifth feature.
Yes.
We have an open reading frame, monocistronic and polycistronic mRNA, and the code is universal. The code is
Universal.
highly conserved in the living world. Highly conserved in the living world. An exception, for example, mitochondrial genetic apparatus.
What is the operating frame?
This is an open reading frame. The
What?
trinucleotide is ORF.
Okay.
Yes. It's written, for example, polycistronic mRNA from prokaryote, and monocistronic is for eukaryote. Oh, no. This is not a tricodon. This is initiation, stop. Initiation, and this is S is
of
stop.
what? Like of.
And this is a mRNA. Okay, in one mRNA, we have a lot of initiation codon and a lot of stop.
Like
it means-
genes? Like.
Yes,
No?
for example, this is a one mRNA,
Yeah.
and in the prokaryote, it produces 3 peptide. But in the eukaryote, it produces just 1 peptide. Because just one initiation, 1 stop.
This is only in eukaryote, and this one is prokaryote.
Yes.
Oh, okay. Okay, cool.
And the code is universal, it's been highly conserved, exception in mitochondrial genetic apparatus.
Okay.
What does it mean is universal? It means this is conserved. Monocistronic is for eukaryote, and polycistronic is for prokaryote. Do you learn it?
Yeah.
I get the handbrake.
Oh, okay. Okay, because. Let me see.
All of them is remain, yes? Fuck me. They are a lot.
I know.
Just this part needs 3 hours.
Because you can go like superficially through them. I can read them. Like, it's just.
I think I take a video by Lisa of this one.
Okay.
But
But I want you to explain me that, because if I don't understand it, then.
آره آره خب قربونش برم فجا
Oh. You don't have to go through very deeply through it. Just